All right, welcome back, Hononegah, Algebra 1, 6.1, Day 4. And I know if this is the year 2021 school year, that we're just coming back off of a long weekend and we're starting second semester here. So, reviewing some things that we've learned. If you want to hit pause and try these by yourself, I will do them for you in just a minute. All right, welcome back. So one of the rules about if you have like-based items and you are dividing, you would subtract their exponents. Now, because the larger number is on the bottom, it should go on the bottom. And then also because it's a number, I would go ahead and evaluate it. So we got 1 over 64. The next one, you would add the exponents on the top. And then when you divide, you would subtract the exponents. Now, a couple different ways of looking at this one. I like to go ahead and do the exponent, and then anything that has a negative power, I would do the reciprocal of. So 3 to the third on top, 2 to the third on bottom, and then evaluate because they're numbers again. And the last one, it gets really complicated all of a sudden with this last one. I see a parenthesis being raised to an exponent. So let's deal with that first. So I have 4 to the negative second, x to the negative 6, y to the negative second. Now, we're going to scroll down here a little bit to give ourselves some more space. Anything that has a negative power needs to be the reciprocal of. So if it's a negative power on top, I'm going to rewrite it on the bottom. So this, and if it's a negative power on the bottom, I'm going to rewrite it at the top. So y to the first would go on the top in the first fraction. In the second fraction, nothing is left on top. 4 squared, x to the 6th, y squared, and a y. Here's what I tell everybody. When you have more than one fraction, you're going to multiply straight across. So across the top, and then I have a y and a y, so I can go ahead and combine those as well. So 8x to the 8 times 1, x to the 4th, y to the 3rd, that's the top. The bottom, 4 squared is 16, and 16 times negative 3 is negative 48. X to the 7th, because I'm taking x to the 6th times x to the 1st. And then y to the 2nd, and y makes y to the 3rd. So there's a lot of stuff that just happened right there. So there's 3 questions left. 8 divided by negative 16, okay, that is negative 1/6. X to the 7th on the bottom with x to the 4th on the top. And these two actually make y to the 0, or just cancel, because the same thing on the top and the bottom is just 1. All right, new stuff today. Scientific notation. What is scientific notation? Scientific notation is using powers of 10. So using powers of 10. And why do we use it? For very large or very small numbers. So what it does is condenses the number into a smaller power of 10. So now, 1.28 times 10 to the 8th. I'm going to go ahead and write this out. So we got a 1, a 2, and an 8. And then 6 decimal places. So instead of dealing with all the zeros, does everybody see all the zeros there? We condense them, and this is just the distance from Mars to the sun. Can you imagine if you had a much even further distance, like from the sun to Pluto or something like that? And then very small numbers. So if I actually wrote this out, and it's a really long one to write out, but I will do it. 2 times 10 to the negative 23rd power. So this is a mass of a carbon atom. So that's how small it is. So now we're going to have so that is a really, really big number. Or really small number, I mean, but very long in length. So this is a much better way of dealing with that number instead of dealing with all the zeros. All right, so how do I write something in scientific notation? First, you need all the numbers involved. So that's what the significant numbers. When you get into chemistry and things like that, they talk about sig figs and things like that, or significant figures. And so again, we just want all the numbers involved. Then, this is an important one. You're always going to make sure that the number in scientific notation must be between 1 and 10. So if you ever get something that's too big, you need to make it smaller. If you ever get something too small, you need to make it bigger. So again, the number needs to be between 1 and 10. And then everything is going to be times 10 to a power. Now, depending on if the number is bigger, or depending on if the number is smaller, is depending on whether or not I use a positive or negative number. And this is the only time you're ever able to use a negative and still leave it in your answer, is when you're doing scientific notation. So if the number is big, positive powers. If the number is small, negative powers. So here we go. 34,000. So I want this number to be between 1 and 10. So in order for this number to be between 1 and 10, I would need to put the decimal place in between the 3 and the 4. Times 10. Remember, I'm putting this in scientific notation. Then it's a matter of how many decimal places. So you're talking about 1, 2, 3, 4 decimal places. And so since the number is big, you're talking about a positive. So if you are counting the decimal places to the left, you're talking about a number larger than 10, and so you would need positive powers. So this one, 1.78, doesn't need to move. So if you were technically putting it in scientific notation, this is 1.78 times 10 to the 0. Next one, there's where I need the decimal place in order to make that number between 0 and 10. 1, 2, 3, 4 decimal places, and it's smaller. Okay, so if you are counting decimal places to the right, that would be a negative power of 10. 4.28, so again, getting all the numbers in the problem. Here's where I want the decimal point to be. 1, 2, 3, 4, 5 decimal places. And the last one, I want the decimal point to be between the 5 and the 2. So 5.21. Let me try again. 5.2314 times 10. And again, counting decimal places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places. And that would be the answer. Now, I want the other way. So write the number in standard form. So basically, you need to understand if you're trying to make the number bigger or smaller. So 10 to the first, I want to make this number bigger by 1 decimal place. So I want to make this one smaller by 6 decimal places. So if you want to, start putting zeros in and count. Otherwise, 1, 2, 3, 4, 5, 6, 7. Or excuse me, 6 decimal places then. So here's where the decimal point used to be. I'm going to erase it. The decimal point used to be right there. So 1, 2, 3, 4, 5, 6 decimal places is how far I moved it. And so that's the new number in standard form. So 1 times 10, here's where the decimal point was. So 0.01. There's 2 decimal places now. I moved it 2 decimal places. 3.28. So I'm going to move it 3 decimal places. 3, 1, 2, 8. 3 decimal places. 1, 2, 3, 4 decimal places, and then the 6, 1, 2. So again, that's 5 total that I moved it. Now you're going to need a calculator. So if you need to hit pause for a second, make sure you hit a calculator. There's 2 parts of this, and then you have to look at your answer. So the first part about this, I take 2.5 times 5.8. So I'm going to multiply the 2 numbers together. So on my calculator right now, 2.5 times 5.8 would be 14.5. Then I'm going to multiply the 10s together and use my exponent rules. 10 to the 4th times 10 to the 2nd makes 10 to the 6th because I'm going to add the exponents. All right. Now this is where I'm going to deviate maybe from some of your teachers, but remember, if you want something in scientific notation, the number has to be between 1 and 10. So you have to look at this number and decide, is it too big, too small, or just right? I call it Goldilocks and the 3 bears, meaning is the porridge too big, or is the porridge too hot, is the porridge too cold, or is it just right? So in this case, is that number too big, too small, or just right? If the number is too big, which this one is, remember it has to be between 1 and 10, you need this number to be smaller, which means you need this number to be bigger. Notice that the arrows go in opposite directions. So if I want to make that smaller by 1 decimal place, then I want to make the exponent bigger by 1 decimal place. So that's where I get the Goldilocks and the 3 bears, too big, too small, or just right. So the next one, 1.82. Now I'm going to have to divide. So I'm going to take these 2 numbers and divide. So 1.82 divided by 1.4. On my calculator, I get 1.3. Now, this is where things get a little bit confusing for some people. I need to subtract. And when you're dealing with negatives, you always need to subtract top minus bottom. So what is negative 1 minus negative 3? Would get you positive 2. Now, is the 1.3 too big, too small, or just right? It's between 1 and 10. So it's just right. I don't have to do anything with it. Remember, when doing scientific notation, that number, the 1.3, needs to be between 1 and 10. Next one, I'm going to take 1.5 to the third power, 10 to the negative 12th power. So both of these are being taken to the third power. 1.5 raised to the third is 3.375. Again, you got to ask yourself, is that number, the 3.375, too big, too small, just right? It's between 1 and 10, so I'm done. It's just right. Hit the pause button. You try these two by yourself. All right, welcome back. So here we go. We're going to take 1.4 times 7.6, and that's 10.64 times 10 to the 7th, because I'm taking 10 to the 4th times 10 to the 3rd. Is this too big, too small, just right? It's too big. It needs to go down, which means this needs to go up. So 1.64 times 10 to the 8th. Last one, 1.2 divided by 4.8. I get 0.25. Top minus bottom. Okay, so when dealing with this, it's easier to just deal with it top minus bottom. You get 10 to the 3rd. Is 0.25 too big, too small, just right? It's too small. It needs to go up, which means the exponent needs to go down. It needs to go up by 1 place, which means the exponent needs to go down, by 1 place. Homework assignment. Please check your Google Classroom as to what the assignment would be. I believe it will be a book assignment on page 296. But again, check your Google Classroom as to what the assignment would be, and good luck.